Welcome to Precision Images, your imaging specialist. We provide Gerber file recreations, laser photo plotting, AutoCAD conversions, and PCB layouts. I would like to introduce you to our senior engineer, Robert Rivera, as he will guide you through our process.
Hi, I'm Robert, and I work here in the engineering department, and I'm going to show you how do we receive, process, and eventually scan a job and generate Gerber data. The first step that we do is to, when we receive the package, we compare what we have here with what was originally quoted. In this case, we quoted for four layers, 2 masks, 1 silk, 7 pieces of film. We got to make sure that they're here. Then we will take a closer look to the film to make sure that the quality of the film is acceptable for our process. If there's any problems, then at this point, this is when we will contact the customer and let them know what's going on with the job. Next, we will prep the job by placing the artwork on a grid where everything is lined up and square. So when we make our scanning paper, we will transfer this to a photographic paper, and we'll use that to scan an image that we will transfer to our software. We will place it on the grid, and we'll line it up everything, and then from here we'll take it into the darkroom, and the next process will be to shoot a photographic image of this on paper. After we validate the artwork and the package that we receive from our customers, we go into a software that was developed for precision images. It's called the Workflow Manager. And here you can track the actual location of every job that is on the engineering department. We start with the lab input, and this is where the job is actually being prepped prior to scanning. You have the scanning edit. This is where the operator, once he start actually editing the job, this is where the operator is going to clock in into the job. This keeps track of the time and the location where the job is at. Then QC, this is where the job goes after the operator is done scanning, and it goes to the QC stage. QC2, this is a second QC stage, just as a double check. Then we have drill QC for those customers that require a drill file. This is where the job will be moved to, and after all these quality areas are checked, then it moves to the transmission stage. At this point, the software will tell us to who the job is going to go to, email addresses, any other information that we may need to know if the customer requires a hard copy of the files sent to them on a disk, or if email is okay. This is where you're going to find all of that, and from this area it gets transferred to the actual invoicing area, and that will take care of the accounting department. Let me show you how this looks, each one of these modules. When you click on them, then you will have a list of all the jobs that we have available at that stage, and you will pick up the one job, open it, and then here you will check what is the artwork quality first, if it's a scan edit or if it's a redraw. That will be if it's film that we're going to be scanning and editing, or if it's a board or from paper media that we actually need to redraw the whole job. The quality of the silk screening and the overall quality of the job. And here's a list of how many layers we receive and how many layers we are to output for the customer. This section here is the section that tells the operator when we are actually scanning the job in the plotter scanner, how to scan it, and if it's a positive or a negative, the size of the actual sheet that we're going to be scanning, and how many layers there is on that sheet. This is where you kind of split the grid in sections. And once you get all of this done, you will close the module, and then it will either ask you to leave it where it's at in the lab input or move it to the next stage. And so far and so on. This is how it goes from every one of these different modules. You have the list, you click on the job, you move it to the next one until it goes to transmission, and then from transmission again you will send it to accounting, and that will take care of our workflow management program. After we place the film on the grid, we tape it to a piece of clear mylar, and then we'll bring it here to the contact printer where we expose the photographic paper. This is what photographic paper looks like. You have an emulsion side and a base side. We will place the emulsion side up, and we will match the artwork emulsion side down on top of the paper. We'll close the contact printer, and then we will draw vacuum on it, and after the machine draws vacuum, we'll do a 1.5 second exposure. After that exposure is done, we will turn off the contact printer and proceed to move the paper to our film process. Another capability that Precision Images has is we're able to reduce artwork. In this case, we have this piece of artwork that is 2:1, and using this camera we can reduce it to size to 1:1, and this camera is extremely accurate, and not everybody has one of these right now. After we expose the paper, we will bring it here. This is our LP 5008 laser scanner. This is an Orbotech machine, and it will hook up directly to our system up front. Once we place the paper on the scanner, you want to make sure that you don't have any air bubbles, and that is as square as possible by using the grid that is on the drum. That's why we had a grid up front that matches this grid on the drum, and it will keep all the films as straight and as square as possible. So once we do that, we will close the plotter, and then we will enter the parameters in this terminal that it will tell it what to name the PCB and where to send it. This will create a file, what is called a contour, and it will send it to our up front to our server, our Orbotech server, and from there each one of the operators can access that file and actually edit it and create the Gerber data. We also use an LP 9008 laser plotter. This is the newer version of plotters from Orbotech. This plotter is dedicated only for our plotting services. We have the capabilities to plot film to a 1/4 of a mil resolution, a 1/8 of a mil resolution, or 1/16 of a mil resolution, according to what our customer needs are. This plotter is also a red film plotter, where the 5008 is a green film plotter, so we have to be aware of the different lighting that we have on our safe room here in the dark room. On our plotting jobs, we use Genesis 2000 software, which is an updated version of the Expert. It came out of the Expert system, and we use this in tandem with the LP 9008 plotter. We have basically what we do here is we will load the jobs, we will arrangement to make it fit the film size that we need, and then we will drop them in the queue in the plotter. The plotter, we can set it up in fully automatic or manual. When we're using this software, we most likely will use the plotter in fully automatic, and the plotter will pick up the film, plot the job, and output it to the output box, where then later we can go out back in the lab and process the film and get it ready to ship to our customers. After we scan the job, we scan the sheets in the plotter. What we get in our system is this, which is called a contour layer. As you can see, a contour layer is basically an outline of the circuit that we just scanned. But we have 6 layers in this case in the one sheet, so we need to split them. What we will do is we will split them by layer designation. In this case, this is the solder side circuit layer, so we will call it S-C. Always on a scan layer you will have the the -C to designate it as a scan layer, and then you will split it. Once you you separate the layer and you split it, then you will go into the editing part. So you pick up the SC layer, and now you just have the single layer. Then we will just move this layer and basically align it to the other layers that you have already recognized. That way the whole job is set up properly, everything is lined up properly, and it will be ready for manufacturing when the customer receives it. When we get the layer that we're going to be working on for editing, the first step that we do is we have to level the artwork. For this case, I'm going to use the crop marks, and I have my snap here set up to the edge of the contour, so it's going to go automatically to the edge of the contour, and I'm going to level it using the crop marks on the board. Then the next step will be to line it up to a known or a layer that I already had scanned and ready. And now I'm going to use the snap to the center of the feature and to the center of the pad here. And the way that we do that is we just use the align command. We pick the layer, the reference layer, which in this case is layer 1. Then we make sure that we have the contour highlighted, and it will snap to the center of the feature and then snap to the center of the pad and execute it, and it should be pretty close to the alignment. As you can see, both layers are perfectly aligned. Then the next step will be to do a quick cleanup of the layer, and that what we will do is we will set a maximum size of 15 mils. Anything that is larger than 15 mils will stay on the layer, and we will pick up everything that is below under 15 thousandths, and then we will check to make sure that no feature is being deleted, because we sometimes get layers that have features that are smaller than that, and we delete that. Then we delete all the whole centers from the layer. We get rid of those, and after that then we do a recognition. You can set up parameters with your vectors, your pads, and we have special pads and SMDs. In this case I'm going to turn on SMDs because the layer has them, and then we do a quick recognition on the board. After we do that, you can see how you have flashes, you have vectors, and you have areas, what we call areas. As you can see here, because I didn't remove the whole center, it didn't recognize the flash that goes there, the pad. Just for the demonstration, I'm going to leave it like that, and I'm just going to move through the editing real quick. The next step will be to unify all the apertures, and on this list you can see that, for example, the round 12 is one that is used quite a bit. That means that mostly all of these traces are drawn with a 12 mil aperture. So we will unify the layers basically using the round 12 trace, and I'm just going to do that one for this demonstration. When you do that, you preview the layers, you're going to see that everything that is around 12 with a plus or minus 2 mils is going to highlight, and that's why all the layers turn, all the vectors turn red. And when you execute that, if you query any of these traces, it's going to be a round 12 aperture. After we do that, then we move to editing. In this case, we will use an editing command of, we're going to replace the pads, and that will be a round 62 flash. We have different options to do this. We can either place it manually like so and execute it, or you can use your other layer and snap to that other layer and just move through and replace the pads that way. Every time that you do that, you remove an area, and once you're done editing, you clear all the areas, then basically what you end up with is that will be the finished layer. As you can see, you have single line vectors, you have flashes, and it's a really clean, almost pure CAD layer. You might have, on this case, it's actually a pure CAD layer. Everything here is single line vectors, flashes. There's no fill areas except the text, and this is something that is acceptable. And that will be how the layer will look after we're done editing. After we're done editing the layer, then we move to the conversion. We're going to convert, because that layer is still not called a Gerber layer, we're going to convert it now into a Gerber layer. And we just execute the command and we save it, and we're done with the editing. After we edit the layer, we move to a different module that is called Edit PCB, and here we will have all the layers lined up, registered perfectly, and here you can do any last minute editing that you might have to do. And here's also where we prepare the job to move to the QC stage. For the QC stage, what we do is we will plot the files that we generated from the contoured layers, and then we will plot the job, and then we will make a diazo shot of those Gerber files and a diazo shot of the Gerber originals, the originals that the customer sent, and from there it will go to the QC department, and the QC department will perform the inspection.
Hi, I'm Bob. I'm one of the engineers at Precision Images that works on the reverse engineering projects, and I'd like to talk to you about part of our inspection procedure. After the new Gerber layers are plotted, we make diazo contacts of the new Gerber layers and the customer's original films. Next step is to bring those to the light table and overlay the negative of the new Gerbers to a positive of the customer's original. The reason we use the diazo film is that it's transparent, and any slight overlapping causes dark spots on the film, and it's easy to detect differences between the two films. The film is examined under magnification. Any differences between the two are marked on the film with any notations that might help the operator correct the problem. After the inspection, the number of the defects are numbered, and the number is written in the lower right-hand corner of the film so that the operator knows how many defects he's looking for. The next step in the process is to inspect the drill if one has been requested by the customer. What we do is we make a copy of the customer's original print. We use that for inspecting the drill, and any defects that are found are highlighted and notated on the copy of the print. Those defects are numbered, and the number is placed in the lower right corner of the print so that, again, the operator knows how many defects he needs to find and correct. After the drill check is finished, the job is returned to the operator for corrections.
We have another piece of software. It's called ScanCAD. It's based on a tabletop scanner, and this is what we use when we get boards to do reverse engineering, or also when we get paper media that is a little bit distorted. Then we will use this system to prep the job, and basically we can redraw the whole job here or get reference layers and transfer them to the Orbotech system and finish the job from there. And once we do that, the process is basically the same as when we get a job from the Orbotech system, and that's how the job will look like. We'll scan the layer, and then from there we can either redraw on top of that, or the software has the capabilities to separate colors and create a reference layer. Once I receive the package back from QC, I will go through the edits that they mark on the inspection sheets, and I will fix them or review them, and then we'll save the file and output the Gerbers just to get them ready to send to the customer. Part of workflow management is to print out this final inspection checklist, where basically we will go through all the stuff that we already did. We had to do this prior to inspection, but this is a reminder, a checklist of the things that we did. Make sure that they're done. If we forget, we can go back and redo them, and then we will send them to the customer and make sure that what they get is what they requested. This will print out, and we will include it with the original media that the customer sent. As we return it to them, we will include this checklist so they have it for their records. Well, I hope that this is helpful for you guys, and if you have any questions, please feel free to call me, Robert Rivera. Also, you can call Bob Wright. He's another very knowledgeable engineer that we have in staff, and we will be more than happy to help you.
This should give you some insight into Precision Image's PCB engineering services. So whether you need Gerber files recreated, laser photo plotting, PCB layouts, or AutoCAD conversions, give us a call at 727-544-0201 or visit us on our website, www.pcbimages.com.